December 7th, Sunday. Can you guys hear me first off? Everybody can hear me, right? You can type in the chat box to answer questions that I ask. Yes, okay, great. So today our topic is going to be divisibility. Uh, right. So first off, definition of divisibility, it means you guys can read when you divide one number by another number, the result is a whole number. So divisible by and can evenly divide by mean the same thing. So first off, these three expressions, the bar over ABC and the underbar ABC and ABC, they're all the same. They just represent like a three-digit number. So like 3, 2, 1. That doesn't represent the digits, the numbers 3, 2, 1. It represents 321. So that's just first a little introduction. Okay, so here are a few like quick divisibility rule tips that are really helpful in math counts and AMC, etc. So first one might be one of the easier ones. It's divisibility rule for 2, 4, 8, and 6. So these numbers are all multiples, all powers of 2. So for example, a number is divisible by 2 if the last digit is divisible by 2. So we know 2 equals 2 to the power 1. So 1 is you look at the last digit. So like, for example, 42. You don't have to care about anything else. All you have to know is that the last digit, 2, is divisible by 2. So for 2 is the last 2 to the power 1, so you get the last digit. So a number is divisible by 4 if the last two digits are divisible by 4. So for example, so we know 4 is equal to 2 to the power 2. So since this is 2, we look at the last two digits. If the last two digits are divisible by 4, then the whole number is divisible by 4. For example, we know 42 isn't divisible by 4, so the number is not divisible by 2. Let's take 140. For 2 is the last 2 to the power 1, so you can hang on. If you could mute yourself, that'd be great. Or if, yeah, we'll mute. Right. So for example, 140. So if the question was, is 140 divisible by 4? Well, first off, 4 is 2 to the power 2, and since this is 2, we look at the last two digits. So all we have to look at is this. So we know that 140 is divisible by 4. So basically, all you have to look at is the last two digits. So if I put like 127, and if I asked you if this number is divisible by 4, the answer would be yes, since the last two digits are divisible by 4. And then similarly, okay. So similarly, we see if a number is divisible by 8 if the last three digit of the numbers are divisible by 8. So for example, we know 8 is equal to 2 to the power 3. So we look at the last three digits. Right, thanks. We look at since 8 is equal to 2 to the power 3, we look at the last three digits. So for example, right, so we look at the last three digits. And the same thing for divisible by 16, we look at the last four digits. So you guys try this example. Which digits, x, will the 7-digit number this be divisible by 4? Right, and I'll keep the divisibility rules up here. So see if you can answer right here in this chat. And keeping into account this right here. All right. Right. I think. All right. These are only partial answers. But right, so I'll explain this one real quick. So it says which digits x will the 7-digit number 3xx6xx2 be divisible by 4? So since it's divisible by 4, we know that 4 is equal to 2 squared. And since it's squared, all we have to look at is the last 2 digits. So x2. So all we have to look at is x2. We don't have to care about anything other than this. So basically the question is asking for which digits x will x2 be divisible by 4? And from here we just list. So like some of you guys got it down here. So for example, we know if x equals 1, 12. 12 is divisible by 4, so that works there. If we put in, for example, x equals 2, 22 is not divisible by 4, so this doesn't work. 32 is divisible by 4, so that works. 42 does not work because it's not divisible by 4. 52 does work, it's divisible by 4. 62 is not divisible by 4. 72 is divisible by 4. 82 is not divisible by 4. And then 92 is divisible by 4. So the answers are 1, 3, 5, 7, and 9. So again, basically, if it's asking for divisible by 4, we look up here, 4 is 2 squared. We only have to look at the last 2 digits, which is x2. We make x2 divisible by 4, and then we just start listing. Okay, right. So try example number 2. How many different 4-digit numbers can be formed using the digits 2, 4, 5, 6, 7, such that no digits repeat and the number is divisible by 4. This one's a little bit tricky, so I'll give you some more time on this one. All right, so first I'll give you guys a little hint. When it asks for how many 4-digit numbers are divisible by this, since there's 4 digits, 2, 3, 4, all you have to really look at are these 2 digits. So basically, your only goal is to make these 2 digits divisible by 4. Okay. Okay, this one's slightly difficult, so I'll explain it, but Golden got closest. The answer is actually 36. So I'll explain it real quick. This uses 2 kinds of math. It uses this, and then it uses combinations, I think. So for example, it says how many different 4-digit numbers using this. So basically, we know that if it's divisible by 4, it's going to be divisible by 2. So the last digit can only be an even number. So the last digit is either 2, 4, or 6, right? So now it says no digits repeat and the number is divisible by 4. So if it's divisible by 4, the last 2 digits needs to be divisible by 4. So basically we just start listing out the number of ways to get it so that the last 2 digits are divisible by 4. So for example, the easiest one I could think of would be 24. So 24 could go at the end, and then the other digits don't even matter. So then also 64 is divisible by 4, and it's in these 2. Also 72, 52, 56, oops, 76. So that's 1, 2, 3, 4, 5, 6. So 6 different numbers can occupy these two spots. And then once you have these two spots occupied, these two digits don't even matter. So let's, for example, let's put 2, 4 here. And then we have 2 digits here, and they don't even matter. So out of our 2, 4, 5, 6, 7, we've already taken out 24 and placed it there. So that this spot, you can have 3 different numbers. So you can have 3 this spot, 3 different numbers here. And then you can have, so then let's say you put a 5 there. Now you have 2 different numbers left, so you multiply by 2. So there's 6. So there's 6 for each set of these. So, and there are 1, 2, 3, 4, 5, 6 numbers. So 6 times 6, and you get our answer 36. So this question is a little bit complicated because it has 2 parts. So the first part is you list out the numbers that have the last 2 digits are divisible by 4, 24, 64, etc. And then you place them there, and then you deal with the other 2 digits, which don't matter after this one. So you can do 3 go here, and then 2 go here, and multiply it. So it's a little bit complicated. Okay, so this one's a little bit easier. If the 3-digit number 788N is divisible by 8, what is N? Right, so nice guys down here, the answer is 4. You can go about this like differently. First off, you can just like plug in numbers and then see which one's divisible by 8. That's a little harder. So you know that if it's divisible by 8, then it's going to be divisible by 2, right? So then we can narrow it down from 1 to 9 to only the even digits. So N can either be 2, 4, 6, or 8. It can also be 0, 2. Okay, so 0, 2, 4, 6, 8. So this is what we've narrowed down to be N. And it also, if it's divisible by 8, then the last 2 digits have to be divisible by 4. So for the last 2 digits to be divisible by 4, this doesn't work, this doesn't work, and you're left with 4, 0, and 8. So instead of having to try like all those 1 through 9, now you have to only try 3, and if you try it, you see that 4, if you put 4 in there, it's divisible by 8. So right, so this generally, the last digit has to be even, and then has to be divisible by 8. Okay, on to the next question. What is the greatest digit? Yeah, okay, we'll do this one. What is the greatest digit that can be placed in the box so that the 6-digit number shown is divisible by 4? Okay, nice job, guys, down here. The answer is 9. Again, it's using the concept of if it's divisible by 4, then the last 2 digits must be divisible by 4. So blank 2 must be divisible by 4. 1 works, but it asks for the greatest digit that can be placed in the box. So the 6-digit number is divisible by 4, and 92 is divisible by 4. So 9 goes in there, and it works out well. Okay, nice job, guys. We'll skip that one. Okay, so this problem is from Math Counts Handbook. See if you guys can handle this. Arrange the 4 digits 1, 2, 3, and 7 so that the 4-digit number you get is a multiple of 8. Right, okay, nice job guys down here. The answer is 7312. 3712 also works, but I'll walk through it real quick. So 4-digit number you get is a multiple of 8. So first off, if it's a multiple of 8, it's going to be a multiple of 2. So the last, right, nice job, Golden. Second one works as well, right? 3712 works. So thanks for muting him. So if it's a multiple of 8, the last digit is it's going to be a multiple of 2, and if it's a multiple of 2, the last digit has to be even. So there's only one choice for that, and that's a 2. Okay, so if it's a multiple of 8, it's also a multiple of 4, right? So if it's a multiple of 4, the last 2 digits must be divisible by 4, and the only ones that work are, you could put either 1 in there, right? 1 works, or you could put 3, right? So then you see that 7312. So 3 can't actually go here because if it's a multiple of 8, the last 3 digits have to be multiple of 8. So 3 has to go here, and then 7 goes here. You could also golden had a second solution, 1, 2, 3, 7, which is also divisible by 8 because 7, 1, 2 is divisible by 8. So nice job. Okay. So that one was a little bit harder, so this is the really easy one. So divisibility rule for 5, 25, 125, and then that's supposed to be a 625, but see, that's 625. So first off, we all know this one, I'm pretty sure. If a number is divisible by 5, if the last digit of the number is divisible by 5. So again, this is like almost the same thing as 2, but this is 5 to the power 1. So since it's 1, you use the last digit. Has to be divisible by 5. And if it's divisible by 5, the last digit could either be 0 or 5. So any number that has 0 or 5 as your last digit is divisible by 5. Okay, so this one is a number is divisible by 25 if the last 2 digits of the number form a number that is divisible by 25. So 25 is equal to 5 squared. So that's where you know you use the last 2 digits of the number that's divisible by 25. Same thing for 125. A number is divisible by 125 if the last 3 digits form a number that's divisible by 125, 5 to the power 3. And you don't really use this one, but it's still good to know. Basically, this is 5 to the power 4, so you use the last 4 digits divisible by 625. Okay. So these are relatively easy to memorize. Okay, so let's try an example. The 4-digit number 6BB5 is divisible by 25. How many such 4-digit numbers are there? Right, nice job. I think everybody got it in. I think that might be a mistype. It's actually nice. Answer is 2. So if it's divisible by 25, 25 is equal to 5 squared. So you use the last 2 digits, and then the last 2 digits, the last 2 digits is B5. And for B5 to be divisible by 25, it can either be 25 or 75. So one of these two. Okay. Okay, so a little bit harder of a question. The 6-digit number 713EF5 is divisible by 125. How many such 6-digit numbers are there? Right, nice job, guys. The answer is 4. So, right, the six-digit number, this is divisible by 125. 125 is 5 to the power 3, so we're basically just looking at the last 3 digits. So we're looking at EF5. And then EF5 has to be divisible by 125. So for example, 125 would work here. And then that's 125 times 1. This works. And then let's another one would be 125 times 2. However, this has 0 as the last digit, so this does not work. So then 125 times 3 equals 375. It has 5 as the last digit, so this works as well. And then 125 times 5 will have 5 as the last digit, so this works as well. And then 125 times 7 has 5 as the last digit, so this works as well. And then when you do 125 times 9, it goes over 1,000. So since it goes over 1,000, it can't fit in 3 digits. So only 1, 2, 3, 4 for such 6-digit numbers. Right, so listed out right here. Nice. Should be divisible at 125. Okay. We'll skip this one. Okay. How many of the following numbers are divisible by 4? But I see we have a little bit of a mix between 3 and 4, but the answer is actually 3. So nice job to the people who got 3 in the end. I think everybody figured out in the end. So we can look at it basically divisible by 4. 4 is equal to 2 squared, so we're only looking at the last 2 digits. So we'll check for 62. If you divide it by 4, it turns out to be a decimal, so that doesn't work. 40 is divisible by 4, so this one is a yes. 24 is also divisible by 4, so this one is also a yes. 28 is divisible by 4, so this one works. 82 is not divisible by 4, so no. And then 42 is not divisible by 4, so no. So only these 3 in the middle work. Okay. And then we can do this one as well. So how many of the following numbers are divisible by 25? Yes, nice job, guys. Answer is 2. So 25 is a little bit easier to do. So just look at the last 2 digits and see if they're divisible by 25. This one works. 75 is divisible by 25, and then this one also works. So 2. Nice. Okay. So divisibility rule for 3 and 9. So I really like this one. It really helps you in math counts. So first off, it's a number is divisible by 3 if the sum of the digits of the number is divisible by 3. So this one is a little bit different from 5 and 2. It's a number is divisible by 3 if the sum, so just add up the digits of the number, is divisible by 3. For example, 3, 9, 3. If the question was, is this divisible by 3? So you could divide it out and see if it divides, or you could just add up the digits, 3 plus 9 plus 3. This equals 15. 15 is divisible by 3, so check, yes. it is divisible by 3. Similarly, for 9, it's a number is divisible not by 9 if the sum of the digits of the number is divisible by 9. So same thing as 3, except for sum of the digits must be divisible by 9. So let's try this example from a real math counts competition. What is the sum of all the possible digits which could fill in the blank 4, 7, blank, 2, 1, so that the resulting 5-digit number is divisible by 3? Right, so it has to be the sum, right? So that's a little tricky part. The next job to you two who got it in the end, the answer is 12. Oops. But I'll explain it real quick since this is a little bit of a harder question. So, yeah, nice, Joseph. The sum of all the possible digits in the blank so that the resulting 5-digit number is divisible by 3. So again, we know that if a number is divisible by 3, then the sum of the digits of the number is divisible by 3. So let's sum up the digits. 4 plus 7. And for the blank, we'll use the variable x. X plus 2 plus 1. This equals 14 plus x. So basically, we're trying to find all the digits x such that 14 plus x is divisible by 3. So 1 works because 14 plus 1 is 15, and 15 is divisible by 3. 4 also works. 14 plus 4 is 18, which is divisible by 3, and then 7 works. 21 is divisible by 3. And then you can't go do any more because then you go above 10, and then you can't, since it's digit, it has to be 1-digit numbers. So now it says sum of all the possible digits, 1 plus 4 plus 7 equals 12. So answer is 12. Nice job, guys. Okay. What is the sum of the next two multiples of 3 after 47? This is also from Math Counts. Right, nice job to the guys who got it over 3. Alex, right, does equal 99. Nice. So it asks for the sum of the next two multiples of 3 after 47. 47 itself is not a multiple of 3 because if you add 4 plus 7, it equals 11, which is not a multiple of 3. But what is a multiple of 3 is 48, because 4 plus 8 is equal to 12, and 12 is divisible by 3. So basically, if we know 48 is a multiple of 3, the next one would be 48 plus 3, which is 51. And then if you add those together, you get 99, which is your answer. So that's for math counts as well. Okay, what is the largest digit which can replace b to make the number 300,037b32 be divisible by 3? Right, nice job, guys. The answer is 8. Um, so it asks such that 437b32 is divisible by 3. So if it's divisible by 3, the sum of the digits must be divisible by 3. So if we add up all the digits, we get 19 plus b. Oops, 19 plus b. And then 19 plus b must be a multiple of 3. So 2 works, 5 works, 8 also works, 21, 24, and 27. And then 8 is the largest digit that can replace, so 8 is the correct answer. Oh, 8 was showing down. Okay. The 5-digit number 31D26 is divisible by 3. Find the sum of all possible values of D. Right, the correct answer is 18. Nice job. Oh, I was showing on the bottom. Okay. So let's try number 5. Find the least possible value of the digit D such that this is divisible by 9. Right, nice job, guys. The answer is 1. Again, we add up all the digits, we get, we add up all the digits, we get 17 plus D, and then it has to be divisible by 9, so 18 is divisible by 9, so D equals 1, and coincidentally, that's also the only value of D that works. Okay, let's try this one. Which number is not divisible by 3? add up all the digits, we get 17 plus D. And then has to be divisible by 9, so 18 is divisible. Right, nice job. Yeah, right, nice job, guys. The answer is 782. If you add up this one, you get 15. This one is 9, so both of these are divisible by 3. But this one is 17, so that number is not divisible by 3. Okay. How many 3-digit numbers in the form 6 blank 4 are divisible by 3? Okay, nice job, guys. The answer is 3. So if it's divisible by 3, you add up the digits, must be divisible by 3, so it's 10 plus x must be divisible by 3. Easiest I could think would be 12, so x would equal 2. 2, and then must be divisible by 3, so 5, and then 8. So 3-digit numbers are divisible by 3. Okay, let's try another example. The 5-digit number 47H20 is divisible by 3. Find all the possible values of H. Nice job, guys. The answer is 2, 5, and 8. I think all of you got that in the end. Again, add up the digits. Digits must be divisible by 3. Okay, onwards. So let's try divisible by 9. Which number is not divisible by 9? So this is from Math Count's handbooks as well. All right, sorry, yeah. The answer is 487. Nice job. Okay, we're gonna skip this one. And then, okay. So divisibility rules for 7, 11, and 13. So these, actually, we'll come back to this. If we have time, we'll come back to these. Okay. So this is a really. Okay. So this is one of the more important concepts. Divisibility rules for 6, 10, 12, 14, 15, etc. So first off is a number is divisible by 6 if the number is divisible by both 2 and 3. So what is important about this is if you multiply 2 and 3, they equal 6. So if you multiply 2 and 5, they equal 10. So basically, if a number is divisible by two numbers that are relatively prime, it is divisible by the product of these two numbers. So like right here, if it's divisible by both 2 and 7, then it's going to be divisible by 14. You could go backwards and say if it's divisible by 14, then it is divisible by 2 and 7. So again, if a number is divisible by two numbers that are relatively prime, then it is divisible by the product of these two numbers. So try this one for math counts computations. What is the greatest three-digit number that is divisible by 6? And I'll leave this up here. So again, divisible by 6 has to be divisible by both 2 and 3, and you can use divisibility rules to figure this out. Right, nice job to those of you guys who got 996. That's the correct answer. So like the way you think about this one is it asks for the greatest three-digit number. So the first two digits should be around really high. So 99 is the greatest they could possibly be. And also it has to be divisible by 6. So if it's divisible by 6, it's divisible by both 2 and 3. If it's divisible by 2, the last digit has to be even. So it could be 2, 4, 6, 8. And if it's divisible by 3, then the sum of the digits must be divisible by 3. So this doesn't work, this doesn't work, 6 works, 8 doesn't work. So 6 is the only one that works. Okay. How many of the first 50 counting numbers are divisible by both 2 and 3? So remember, if it asks for both 2 and 3, then it's going to be divisible by 6. So it's basically asking like, how many multiples of 6 are there under 50? Okay, so this one's a little bit tricky. I see we have like 9, 8, 6. So I'll explain it. So if it asks for the first 50 counting numbers divisible by 2 and 3, so it's basically asking out of the first 50 counting numbers, how many are divisible by 6? So you could also, like first off, you could start listing. You go 6, 12, 18, 24, and then just list till you got to 50, which would be relatively easy to list. But also you could go 50 divided by 6, and then you would get 8 point something, etc. So then from this you know that there are 8 multiples of 6 under 50. So basically it's 6 times 1, 6 times 2, etc. till 6 times 8. which is equal to 48, which is under 50. So 1 to 8, they're a total of 8. So you could either list or you could divide 6 into 50, get a decimal, and then figure out that it's 8. Okay. Try example number 3 from Math Counts Handbooks. For what digit n is the 5-digit number 3n85n divisible by 6? Right, so I think most people got the answer 4 in the end. Nice job. I'll walk through it real quick. If it's divisible by 6, it must be divisible by 3 and 2. So we know the rules for 3 is the sum of the digits must be divisible by 3. So first off, we'll sum up the digits. We get 16 plus 2n. This must be divisible by 3. So it's only divisible by 3 when n equals 1, 4, or 7. So basically you just like plug numbers in and try. So like 1, you get 18, and 18 is divisible by 3, so 1 works. 2, you get 20, 20 is not divisible by 3. Or you could count up by 3, that works too. Okay, so then it says if it's divisible by 6, it has to be divisible by 3, so it's one of these digits, but it also has to be divisible by 2, since it's divisible by 6. If it's divisible by 2, the last digit must be even, so 1 and 7 both don't work, so the answer is 4. Okay, let's try this one. How many numbers less than 100 are divisible by 3 and are also divisible by 4? Right, nice job, guys. The answer is 8. So if it's asking for divisible by 3 and 4, it must be divisible by 12. So basically, we list out the multiples of 12 less than 100. The first one is 12, 1 times 12, and then etc. on to 8 times 12, which is equal to 96, which is the largest. So 1 to 8, total of 8. Nice. Okay, let's try this one. Given the 4-digit base 10 number, so basically normal number, 77A4, for what value of the non-zero digit A will this 4-digit number be divisible by 3 and 4? So since this one's a little tricky, I'll give you guys a hint. Oh, well, I got an answer. Okay, I'll give you guys a hint. It has to be divisible by 3 and 4. So first make it divisible by 3. So add up all the digits and then find the numbers, find the digits A that make it so that it's divisible by 3, and then handle divisibility by 4. Right, nice job, guys. I see everybody's gotten 6. Very nice. So I summed up all the digits right here, and I got 18 plus A, and we see that it has to be divisible by 3 first off, so this whole thing must be divisible by 3. A can either equal 0, 3, 6, or 9. And then it also says it must be divisible by 4, so A must be even and non-zero. So first off, 0 doesn't work, 3 doesn't work, 9 doesn't work. So the only digit we're left is 6. Okay, onwards. So if the 4-digit number 273x is divisible by 12, what is the value of x? Nice job, guys. All I see is a bunch of 6s. 6 is the correct answer. Coincidentally, is the answer of the other one as well. Just a bunch of 6s. Okay, I'll explain it again. 273x is divisible by 12. So if it's divisible by 12, it's going to be divisible by both 4 and 3, since 4 times 3 is equal to 12. So first off, let's handle divisibility by 3. So let's sum up the digits. 2 plus 7 plus 3 plus x is equal to 12 plus x. And then 12 plus x must be divisible by 3, so x must be a multiple of 3 for this whole thing to be divisible by 3. So it could be either 0, 3, 6, or 9. 9. And then we look at, so it must also be divisible by 4. So if it's divisible by 4, then it's also divisible by 4. So it's also divisible by 2. So the last digit has to be even. So automatically these two are crossed out. And then the last 2 digits must be divisible by 4. So 3x must be divisible by 4. 30 is not divisible by 4, but 36 is divisible by 4. So 6 is your final answer. I think we have time for one more problem. So find the value of x such that the 4-digit number x15x is divisible by 18. Right, nice catch there. It could only be 6 because it can't be 0. It'd be a 3. three-digit number. So nice job to everybody who got it. The answer is indeed 6. Again, if it's divisible by 18, it's divisible by both 2 and 9. So you can add them together and you get 2x plus 6 if you add up all the digits. This 2x plus 6 must be divisible by 9, so x equals 6 is the only value that's possible. Okay. I think we'll do one last problem. So example number 8. Which digits, I think this might be one of the harder ones, should replace the tens digit d such that the 7-digit number, this is divisible by 24? I think this is one of the harder ones. And we'll end with this one. So I'll give you guys a quick hint. So divisible by 24, 24 equals, it is equal to 3 times 8, right? So it has to be divisible by both 3 and 8. So you guys can go from there and see. Right, nice job to the people who got 0. The answer is 0 in the end. So if it's divisible by 24, it's divisible by both 3 and 8. So first off, we'll handle 3. The sum of the digits must be divisible by 3 first off. So we'll add up all the digits. We get 30 plus d. And then 30 plus d must be divisible by 3. So 0, 3, 6, or 9 could be d. And then we look at the last 3 digits, 5, blank, 4. And then we just plug in all these numbers to see which one is divisible by 8. And it just so happens that the first one, d equals 0, is the one that works. Okay, guys, thanks for being here today. We'll have class again next Saturday, same time, 4 p.m. And the class notes and homework will be posted on the forum. So that's the end of class today. Thanks for coming. Bye.